Dear students, today topic is SR flip-flop, right? We know that the flip-flop is nothing but the additional control input with latch circuit is called as the flip-flop. Here we are using a set and reset state, so that's why it's called as a SR flip-flop, right? So the SR flip-flop consists of two additional NAND gate at the S and R input of SR latch. The clock input is connected to the both of the NAND gates, resulting in low outputs when the clock input is low, right? So SR flip-flop is nothing but the two additional NAND gate is at the SR input of SR latches. Here clock input is connected to the both of the NAND gates, right? Here the clock is what type of triggering? Here we applied level triggering, positive level triggering, which means the next state change will occur only when the level triggering of 1. So whenever the clock signal reaches at the level 1, that time only it's possible to change the next state from the previous state. If the level is 0, then there is no change at the output. The output will be the same as the previous state. There is no change at the output when the clock is 0 level triggering, right? This is the concept of level triggering. Let's consider the operation of the SR flip-flop, right? So in that SR flip-flop, we are using the NAND SR latch. So for calculating the SR flip-flop truth table, we must know the NAND SR latch truth table. So this truth table in previous video, I derived this truth table, right? You just go and refer it. Let's see the SR flip-flop operation, right? Let's consider if the clock signal is 0, right? Which means it's a 0 level triggering. Then what happen if SR input, it may be 0 1 or 1 0 is not a problem, which means XX, it may be a 0 1 or maybe a 0 1, it's not a problem because here we are using NAND gate. One of the input is 0, so one of the input is clock. If clock signal is 0 means obviously the NAND gate output is 1, right? So the NAND gate output is 1 means both output are 1. So this 1 1 is nothing but input of that SR NAND latch. Okay, we already derived the SR NAND latch truth table, right? So in that SR NAND latch truth table, inputs are 1 1. The next state will be the previous state, right? So here also the next state will be the previous state. Okay, Qn. If previously Qn is 0 means in this condition also Qn is 0. There is no change at the output, right? It happens when the clock signal is 0. If we want to change the output from the previous state, we must apply the clock is positive level triggering, which is nothing but clock signal is 1, right? So whenever the clock signal is 1, that time only there is an output change occurred. Okay, let's see the possibilities of SR, right? So the first possibility is 0 0. Let's consider S is equal to 0 and R also 0. Then what about the second input of both gates? 1 1, because clock signal is high. Clock signal is 1. So both inputs are 1, clock inputs. But the another input of both gates are 0 0. So 0 0 means what happened? The NAND output is again 1 1. We know the NAND SR latch truth table 1 1 combination provide the next state will be the previous state. So in this combination also the next state will be the previous state, right? Qn. Okay, then what is the next possibility? Clock signal is 1, SR is 0 and 1. So in this case now S is equal to 0, R equal to 1. In this case S is equal to 0, R equal to 1, right? Clock input always 1. So one of the input is 0, the NAND output is 1, right? For 1 1 combination the NAND output is 0. The 1 and 0 is the input of NAND SR latch. So NAND SR latch 1 0 combination provide the output is 0. So 0 1 combination provide the output is 0, right? Then next possibility is 1 0, right? Now S is equal to 1 and R equal to 0. The another clock input of both the gate is high, right? So 1 1 combination provide the output is 0. 0 1 combination provide the output is 1, right? This 0 and 1 is the input of NAND HR latch. The output is 1. So here the output is 1, right? Then the last possibility is clock signal is high and both inputs are 1 1, right? If S is equal to 1, R also 1. 1 1 combination provide the 0. Here 1 1 combination provide the 0. So SR NAND latch input both are 0 0 combination provide the next state is forbidden state or invalid state. So here the next state will be the invalid state. So these two cases are no change, and this is a reset state, and this one is a set state, and this one is a invalid state, right? So now this is the truth table of SR flip-flop. Whenever the clock signal is high, that time only there is a possibilities of output changes. When clock signal is 1, then output changes from Qn to Qn, but the input is 0 0. The output change occur which depends upon the or with respect to the input combination. Now the Qn is changes to 0 when clock signal is high and the input is 0 1. Then the next state changes 0 to 1 when at the clock input is high and also the input combination is 1 0. So this is the truth table of SR flip-flop, right?